Hello, welcome to the next video in a playlist that I'm calling General Linear Models, Design of Experiments. And we're in part 10 of a little mini-series that I call One-Way Fixed Effects ANOVA. And in part 10 we're looking at partitioning the sum of squares treatments. And in parts 7, 8, and 9 we look at contrast, the sum of squares of contrast, we look at the variance associated with the least squares estimates, we calculate the least squares estimates. Part 9 we start looking at orthogonal contrast, and in part 10 we show that that set of orthogonal contrast actually partitions the sum of squares treatment, and that's what we want to illustrate in this video. Now in part 9 we develop these four contrasts. Now the rows, the way that I've printed them here, so this is a contrast. Notice that the components sum to 0, and the same way for the other four. Now these were generated randomly, and generate means I just thought them up, and that's and so it's really for illustrative purposes. But in practice you want to generate meaningful contrast. Now sometimes you can generate 2 or 3 meaningful contrasts, and the fourth contrast, orthogonal contrast, may not be meaningful. But anyway, that's sort of a reality associated with it. Now, to do this in R, we need to take these four contrasts and shove them into this factor, which is treatment. Now, let me back up. I'll need to do this. Now, this is also under the assumption that you've followed the first 9 videos. So I need to load these, and we're looking at an experiment or an example from Montgomery. The book title is Design and Analysis of Experiments. It's the 3rd edition. We're looking at example 3.1, which is a tensile strength experiment. Now, tensile strength is how much force does it take to tear something apart. Here we're looking at fabric with different percents of cotton in it. So there's a fabric with 15% cotton blend, 20, 25, 30, and 35% cotton blend. And we're analyzing that. We've gone through these. So now we're on part 10, and I'm running the first 9 parts, or technically it's 8 because we skipped one part. And now we're on part 10. So we've loaded the previous, and let me reprint these contrasts. Now to do this in R, we take the 4 contrasts and we put them in an attribute of this treatment factor. So TSE stands for Tensile Strength Experiment. That's what I created. It's a data frame that has 2 columns. One is Y, the tensile strength, and the other is a treatment vector, and it's a contrast. So now once we load these contrasts into the attribute for that factor variable, then we rerun our ANOVA tensile strength by treatment. So it's a one-way fixed effects ANOVA. We're using data set TSE, and I store it in a variable OWFE, which stands for one-way fixed effects. Now we could just summarize the OWFE, and we create the ANOVA table. But here we're using the split function to split the treatment factor, into these 4 orthogonal contrasts. Let me just show it. So this is the ANOVA, and so this would actually be a normal ANOVA table, but we've added these 4 rows, and that's what the split does. It splits this treatment into these contrast sums of squares. And if you were to add the sum of squares associated with these 4 contrasts, it would actually equal the treatment sum of squares. So 1 right there is proof that it does partition the sum of squares treatment. But also in 10 we calculated these sum of squares by hand. So the least squares estimate for contrast 1 is actually this formula here. It's the linear combination of the y squared, divided by this. And let me just print it and I'll show you. So we printed this, and it's 291.6, and it's exactly what we got here for this contrast. So it is the sum of squares for this contrast. And we use this formula in previous videos to show that it does work. But here I'm showing you that we do get the values that we are in this ANOVA table. So then 3, we get 151.1, which is what this one is. And the fourth contrast, sum of squares contrast, is 80, 0.81, which is that treatment sum of squares contrast. Now also in previous videos, we, let me reprint this summary table. Now in previous videos we showed how to derive the mean squared error, which is the sum of squares divided by its degrees of freedom. We derived the f value and we derived the p value. So we're not going to do that in this video. We just really wanted to illustrate that the sum of squares associated with these contrasts does partition the sum of squares for treatment. The next video, now sort of jokingly, I wasn't going to do this, but I think I'm going to. We're going to look at the residuals after fitting this one-way fixed effects ANOVA. I'm just going to call it part 10 of 11 so I don't have to change all the other videos to part, to 11. And actually, I only talk about 10 parts, and so it'd be weird if it was really 11, but I only talk about 10. So I'm sort of jokingly just going to call part 11. Well, that's all I have for this video. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.